Good day everyone. In this video, we're gonna talk about Chapter 5, Fundamentals of Fluid Flow. Here is our problem in this chapter. Through a pipe with a diameter of 500 millimeters and a pressure of 15 kilopascals, water enters a motor. It exits through an exhaust pipe with a 1000 millimeter diameter and a 5 kilopascal pressure. The centers of the two pipes at the parts where the pressure is measured are separated vertically by 300 centimeters. Calculate the power in horsepower delivered to the engine if 490 liters of water pass it every second. Listing all the given, we get diameter on section 1 equals 500 millimeter, which is also equal to 0.5 meters. Diameter on section 2 equals 1000 millimeter, also equal to 1 meter. Pressure on section 1, which is 15 kilopascal. Pressure on section 2 is equal to 5 kilopascal. Z is equal to 2.5 meters. And Q is equal to 490 liters per seconds, which is also equal to 0.49 cubic meter per seconds. Find P. To solve for P, we must first solve for head turbine. Head turbine is given by the equation E sub 1 minus HE equals E sub 2, where HE is the H turbine. E sub 1 minus HE is equal to E sub 2. E sub 1 is also equal to V sub 1 squared over 2G plus P sub 1 over gamma plus Z sub 1 minus HE equals E sub 2, which is also equal to V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2. Note that V squared over 2G in pipe is equal to 8 times the volume flow rate, which is Q squared over pi squared times the acceleration due to gravity times the diameter raised to 4. With this, we get 8 times the volume flow rate, which is 0.49 squared divided by pi squared times 9.81 times the diameter on section 1, which is 0.5 meters raised to 4, plus the P sub 1, which is 15 kilopascal over 9.81 plus Z sub 1, which is 3, minus HE equals 8 times 0.49 squared over pi squared times the acceleration due to gravity, which is 9.81 times the diameter on section 1, which is 1 raised to 4, plus the P sub 2, which is 5 kilopascal over 9.81 plus the Z sub 2, which is 0. So calculating, we get HE equals 4.317. After solving the HE, we can now solve for the power. Power is given by the equation P equals Q times gamma times HE, where P is power, Q is the volume flow rate, gamma is the unit weight, HE is the H turbine. Plugging in all the values, we get 0.49 times 9,810 times 4.317. Solving, we get 20,751.39 watts. Since in our problem, we need to calculate the power in horsepower, we need to convert 20,751.39 watts into horsepower, which is equal to 20,751.39 watts times 1 horsepower over 746 watts. Calculating, we get P equals 27.82 horsepower. And this is our answer in this problem.